This is for Year 12 methods. It's exam focus 13. It's a question about transformations and comes out of exercise 4.1. It's actually a question from the VCAA 2007 exam 1 question, so it's technology free. The first part of it involves solving a trigonometric function, and the second part involves considering transformations. So let f be the function of the domain R, and f maps for all real functions to all real numbers. F of x equals the sine of 2 pi x divided by 3. In part A, it just says solve sine of 2 pi x over 3 equals minus root 3 on 2 for x going from 0 to 3. So this isn't about f. It's got a restricted domain of 0 to 3. It does, however, happen to have the same rule as what f has, but it's only from 0 to 3. Okay, so x goes from 0 to 3. I wonder what this goes from. So 2 pi x, multiply everything by 2 pi, so 0 to 6 pi, and then 2 pi x on 3. That divided by 3 is 0, that divided by 3 is 2 pi. So in actual fact, all stations to Coburg, I've got one revolution. Where will sine be negative? Sine will be negative in the third and the fourth quadrant. Therefore, 2 pi x on 3 will equal pi plus theta and 2 pi minus theta. We're in the first quadrant. Theta is going to equal, for a sine to be root 3 on 2, theta's got to be pi on 3. So 2 pi x on 3 equals pi plus pi on 3, which is 4 pi on 3, or 2 pi minus pi on 3, which is 8 minus 1. It's on 3. 6 minus 1 is 5 pi on 3. Multiply everything by 3. 2 pi x equals 4 pi or 5 pi. Divide by 2 pi, x equals 4 divided by 2 or 2. And 5 divided by 2, which is 5 on 2. So there are my two answers. Now, what do I know about this? This will have a period of 2 pi divided by 2 pi on 3, or 3. So, here it is, all the way up to 3. That will be 1.5. And where is it minus root 3 on 2? Well, it's equal to root 3 on 2 at that value, which is 2, and that value, which is 2.5. My two answers for x. And that makes sense. When drawing the sine curve, it's a positive sine, therefore it will be positive first, then 0, then negative, and those two values of x make a bit of sense. Okay, let's consider part B. Let G equal all real numbers mapped to all real numbers. G of x equals 3 times f of x minus 1 plus 2. So G is a transformation of f. And f is the same as this function I solved in part A. So f, if I had a restricted domain, would look like this. Find the smallest positive value of x for which g of x is a maximum. Okay, what is the smallest positive value of x where f of x is a maximum? And that's it just there. That's the first maximum that I come to, and that value down there will be a half of 1.5 or 3 on 4. So for f, the lowest, smallest, the smallest value of x for which f of x is a maximum is x equals 3 on 4. Now I need to do it for g. Now what's happening to f to turn it into g? I've got 3 f of x minus 1 plus 2. I've got a transformation by a factor of 3, which is a dilation, and that's away from the x-axis. So that's going to make the curve look like this by a factor of 3. Is that going to affect the lowest value of x where it's a maximum? No, the maximum is still 3 on 4. What's the plus 2 going to do? That's going to move up a value of 2. If I move up a value of 2, will that change when the lowest value of x becomes a maximum? No, 3 on 4 is still going to be the lowest value. What's the minus 1 going to do? It's going to move it to the right. Move it to the right 1 unit. Will that change when the first maximum occurs? Absolutely. This point here gets moved over 1 whole value. This point gets moved over 1 value. This point gets moved over 1 value. This point gets moved over 1 value. And the point that was over here at -1 gets moved over. Now, this point will now go to 3 on 4 plus 1, which would be 7 on 4. Will from here another maximum value of the function come into the positives? No. X has to be a positive value, so the smallest value of x that makes g of x a maximum is x equals 3 on 4 plus 1 or 7 on 4.